Hello, everyone. I'm the digital marketing lead at Typhoon Hill and the host of our Spotlight series, where we talk to leading researchers and engineers using cutting edge technology to design and test power electronics and power systems. Our next guest is Professor Subhashish Bhattacharya, one of the founding faculty members at FREEDM Systems Center at North Carolina State University. Hello, Professor.
Hello, how are you doing?
I am doing great. I'm so glad you're here. It's very special. And I want to go ahead and get started with asking you what are the major challenges of integrating distributed energy resources in DC microgrids?
So let's say we have multiple loads and sources connected to a DC microgrid, and let's say one of the load or one of the source goes into a fault condition. In that case, your controller will see that impact of that fault with the DC voltage at the point of common coupling. So that is one example where the controller must know what to do.
How realistic are these models to design and test a DC microgrid?
One can emulate a real converter, a real switching converter with switching models in the Typhoon system. And once you validate your controller on the Typhoon system, then there is no need to do any more changes to the controller before you can actually put it on to your real converter. And that's the powerful thing.
How did this hardware in the loop help you transition from a lab setting to making a product for industry?
Hardware in the loop enormously actually reduces your cycle time of transitioning from active research to validation and to a field deployment and industry validation part of it.
And can you give an estimate of the time period? You said it reduces the cycling time enormously.
Yeah, so for a small DC microgrid system, I could safely say that you would reduce where you might have taken 3 months to 4 months to almost 1 or 2 weeks. So it's a huge difference.
Have you had the same results of reducing that cycling time in getting funding and publishing your work on DC microgrids?
This whole concept of rapid prototyping or rapidly going to making sure you have gone through all the corner cases and looking ahead to all the disturbances and all the conditions enormously helps to answer questions that the funding reviewers typically have, because before they have asked you that question, you can actually anticipate and give those answers. And also from the publishing point of view, you have already made a very comprehensive test case, and so it takes away all those unknowns and questions.
I know you've used several systems, not just Typhoon. You've used systems, other hardware in the loop platforms. So how would you describe your experience with Typhoon Hill compared to other Hill solutions?
I think what is very important in all these real-time systems, or where Typhoon distinguishes, is the robustness of Typhoon and also the ease of use.
And this is the last question I ask everybody in the Spotlight series. What's the one word you would use to describe your experience with Hill?
I would say excellent.